Hello students, good morning to all of you, and myself is Dr. Santosh Choudhury, editor in chemistry, and today we will discuss the chemical reactions of alkyl halide. Last class we have discussed the substitution reaction. The alkyl halide undergoes the substitution reaction, means the halogen atom of alkyl halide is substituted by the other stronger nucleophiles. By the substitution reaction, we can prepare a various class of organic compound from alkyl halide. We can prepare the alcohols, ether, ester, primary amines, carboxylic acid, alkyl cyanide or alkyl nitriles, etc. from alkyl by substitution reaction. And today we will discuss the elimination reaction. The alkyl halide undergoes the elimination reaction. So what is the elimination reaction? Elimination reaction means eliminate the two atom or group from the consecutive carbon atoms. So what is elimination reaction? So this is your X, this is your, suppose this is your Y. Elimination reaction means that two atom or group can be removed from the consecutive carbon atom of the molecule is known as elimination reaction. So when this eliminate, this HX, this will be go to here, this will go to here, so it became C double bond C. It result to form alkene plus X5. This type of reaction is known as elimination reaction due to elimination of XY from the substrate molecules. This kind of known as elimination reaction. And the alkyl halide undergoes the elimination reaction. That means the halogen atom of alkyl halide and the hydrogen atom. This halogen atom, this is your alkyl halide, and this halogen atom of one carbon atom and neighboring carbon. You see the neighboring carbon, this was neighboring. Or we can write another carbon here. This is neighboring carbon atom. So elimination generally taking place. The halogen atom of one carbon atom eliminate H hydrogen atom by the neighboring atom or consecutive or neighboring carbon atom. As a result, this will result to form the C double bond C like this. A result to form alkane. This type of reaction is known as elimination reaction, and there is a loss of what? HX. This is called dehydrohalogenation. D means loss. What loss? Hydrohalogen means HX. That's called dehydrohalogenation reaction. And the elimination may taking place from the alpha carbon atom. This is your alpha carbon as with respect to this carbon, or you can say this is also alpha carbon with respect to this carbon atom. So alkyl halide undergoes the elimination reaction result to form an alkene. And how the elimination is taking place? When I put a arrow mark, will it? No. We use some eliminating reagent, that is, you are using some eliminating reagent. That eliminating reagent must be a strong base which can remove a proton. Proton means H plus sign. So the eliminating reagent must be a strong base which will be remove a proton from the alpha hydrogen atom. Generally, eliminating reagents are alcoholic potash, means this is called alcoholic potash. So this is ethyl alcohol and KOH. That means the KOH is solid, ethanol is liquid. When KOH is dissolved in ethyl alcohol, that gives alcoholic potash. This is called what? Alcoholic potash. You see, this alcoholic potash means ethyl alcohol plus KOH. They react to form C2H5O minus plus H2O plus K plus. This is a very strong base. The another eliminating reagent is sodamide, NaNH2, sodium amide. The sodium amide produces for the NH2 minus, which also a strong base. So the alkyl halide when treated with eliminating reagent like alcoholic potash or sodium amide, it undergoes the elimination reaction by losing a molecule of HX to form the corresponding alkene. Generally, this is used for the preparation of alkene, means we can convert the alkyl halide to alkene easily by treating some eliminating reagent. Okay, students? Now, what is the reactivity order? The reactivity order of alkyl halide towards elimination reaction, that is tertiary alkyl halide is more reactive than secondary alkyl halide is more reactive than primary alkyl halide. What is tertiary alkyl halide? That is, this is your tertiary alkyl halide and this is your secondary alkyl halide and this is your primary alkyl halide. The order is like this. The tertiary alkyl halide more eliminate or easily eliminate as compared to secondary, as compared to primary. This is due to stability of the intermediate carbonium ion. You know, the stability order of tertiary carbonium ion is more stable than secondary carbonium ion, is more stable than primary carbonium ion. Okay, students, now we know what is elimination reaction and how the elimination reaction taking place by the alkyl halide the alkyl halide undergoes elimination reaction to form the corresponding alkene by losing a molecular halo acids HX. That's why this elimination reaction is called dehydrohalogenation. D means loss of HX. Okay, students. Now we will come to how the elimination reaction taking place by the alkyl halide. So, suppose you take a primary alkyl halide RCHHCH2X. This is your primary alkyl halide. Okay, that is, this is the carbon which possesses halogen atom, and this halogen atom, the nearby carbon alpha carbon. When I treated with alcoholic potash, means ethyl alcohol plus KOH, the elimination taking place, this will eliminate out, and this bond can form a pi bond. So the result gives RCH double bond CH2. This is your alkene, and it gets lost molecule of HX. This HX is a acid and KOH is a base. They react to each other to form salt and water. Okay, student. Suppose I will take the bromo ethane. When treated with alcoholic KOH, what will happen? The bromine atom of this carbon atom and the hydrogen of this one get lost molecular HPR. So this bond will come to here, it became a double bond, this became, one H is get lost, this became CH2 double bond, this bromine is left, then this is CH2 plus KBr plus H2. Are you following me? That means the CH3 means CH2H, CH2Br. When treated with alcoholic KOH, the bromine atom, this carbon atom, and hydrogen of the alpha hydrogen, alpha carbon. It is result to form what? CH2 double bond, CH2 plus KBr plus H2. Okay, suppose I will take another compound two bromo butane. Suppose I take two bromo butane. So mark this, this is the carbon atom who is having bromine atom, and this carbon is alpha, this carbon also alpha. So this is the conjugated carbon atom of this one, that is the carbon atom which contains the bromine atom, that carbon is alpha, and this also is alpha carbon. Okay, and what about this? This is beta. So elimination generally taking place from either side or this side, because it has a 2 alpha carbon atom. So we will get a 2 type of product. One double bond will be this is one by losing this bromine and this one. In some other molecules, the double bond will create here by losing Br and H. So we'll get a two type of product when treated with a eliminating reagent, that is your alcoholic potash, and this became CH2 Br H. This is lost molecule CH2 double bond CH, CH2 CH3 plus KBr plus H2. It is in one molecule. Suppose other molecules, the elimination taking place. This is suppose one path, and this is path 2. What will give? That is CH3 CH double bond, because the elimination taking place between these two. CH2 CH CH3 CH double bond CH CH3 KBr plus H2. That means the alkyl halide which had two alpha hydrogen atom left hand side and the right hand side will get a two type of alkene, and this alkene is called but 1 ene, and this alkene is called but 2 ene. So this case does not arise it hydrogen atom, and this is what type of? This is one type of secondary alkyl halide. So between these two products, both are get equal amount? No, both are get does not have equal amount. Out of these two products, one is major, another is minor. And this is the major product, and this will be the minor product, and this will be the major product according to a rule is there, that is called Say-Jeff's rule. Say-Jeff's rules means the elimination of alkyl halide taking place from the alpha hydrogen atom which have more branching. Which alpha carbon is more branching? You see in this molecule, this is your alpha, this is your alpha, and this is no branch, but it has a branch. Mark this, this carbon has one branch, but this carbon has no branch. That's why this side elimination will be measured more as compared to this one. That's why butene 2 is the major product and butene 1 is the minor product. And this is according to what rule? Say-Jeff's rule. That is, Say-Jeff's rule means the elimination of alpha carbon atom is taking place, means the alpha carbon atom lost a proton which is more branching. And this is due to the stability of intermediate carbanion ion. That means the carbonium ion which is more stable, that will give the product. Okay student, you can do so many examples of alkyl halide by elimination reaction, and the elimination reaction, that is, suppose you will take CH3 CH CH3 CH2 Br, when treated with alcoholic potash, and this will lost HBr, this became CH3, C, CH3, double bond, CH. This is your isobutene or 2-methyl prop 1 ENA. Suppose I will write a compound. Suppose this is your now this group is CH3. When this compound, what is the name of this compound? That is 1-methyl, 1-bromo, 2-methyl cyclohexane. When treated with alcoholic KOH, you see this is the carbon atom and this is alpha, this is another alpha, but this alpha is more branched as compared to this one, this alpha. So elimination is taking this side, so it will form, that is 1-methyl cyclohexene. Okay, student, you can practice by taking the various example of alkyl halide that treated with alcohol potash. It undergoes elimination reaction, that is dehydrohalogenation, to form the corresponding alkane. Now, can you differentiate when the alkyl halide treated with aqueous potash and alcoholic potash, what will gives it is? Suppose I will take CH3, CH, Br, CH3, that is 2-bromo propane. When this 2-bromo propane treated with aqueous KOH and treated with alcoholic KOH, means the potassium hydroxide dissolved in water. Here the potassium hydroxide dissolved in ethyl alcohol. You will get same product. No, you will get different product because this one gives substitution reaction, this one gives you elimination reaction. The product is CH3, CH, OH, CH3. This is propane 2OL, and this is called substitution reaction, SN reaction. And what product will get? It undergoes elimination reaction. It gives you CH3, CH, double bond, CH2 plus KBr plus H2O, but here it gives you KBr. And this is your propene, prop 1 ENE, and this is E reaction, elimination reaction. Okay, you see, we can prepare the alkene from alkyl halide by elimination reaction. Means the alkyl halide is treated with a suitable eliminating reagent, that is particular alcoholic potash. Okay, students, and this is all about your elimination reaction. In elimination reaction, we learn the Sage's rule. Sage's rules means the elimination can taking place from alpha hydrogen atom which have more branch site. That became a major product. Okay, students, this is all about your elimination reaction. Next we come to reaction with metal. So, reaction with metal. But alkyl halide react with the metal, that means active metal like sodium, magnesium. You know, in alkane chapter, the higher alkanes can be prepared from alkyl halide by Wurtz reaction. What is this Wurtz reaction? That is two molecules of alkyl halide react with metallic sodium in dry ether to form the higher alkane. Means what the number of carbon atom in alkyl halide, the alkane is double. That is, the alkane possesses double number of carbon atom, and that reaction is called Wurtz reaction. Similarly, you will study here the Wurtz reaction, that is two molecules of alkyl halide react with metallic sodium to form the higher alkane. So, first come to reaction with sodium. So, two molecules of alkyl halide, that is RCH2X2Na plus XCH2R. This is one alkyl halide. The another molecule of alkyl halide, when one with dry ether medium, what will happen? This X of one alkyl halide and another X from another alkyl halide, it get lost two molecular NX. Now it gives you RCH2 CH1. You want to create between this and this one, CH2 CH2 R plus 2 NX. This is your alkane. And this reaction is known as what reaction? Wurtz reaction. In Wurtz reaction, always form symmetrical even member alkane. Means we can prepare ethane, butane, hexane, octane like this. That means we cannot prepare methane, propane, pentane like this, because this became double. This called what reaction? Wurtz reaction. For example, if you take suppose ethyl bromide, two molecular ethyl bromide, heat with metallic sodium in dry ether, what will happen? This became double. This side is double. So this became CH3, CH2, CH2, CH3. This is your butane plus 2 Na. Suppose I will take two bromopropane CH3 CH CH3 Br. Suppose you take two molecules, heat with sodium in dry ether, and this will be removed and link will there What will happen? CH3, CH, CH3, bond, newly bond created here, it became CH, CH3, CH3. This is 2,3 dimethyl butane. Okay, students, how it is? This is that is CH3, CH, CH3, Br, one molecule. This is 2Na, and this is another molecule. When you heat this, it gets lost to NaBr. And when it lost, it gives this molecule. And this type of reaction is known as what reaction? Wurtz reaction. What reaction? Wurtz reaction. Okay, so when suppose you take one molecule of aliphatic alkyl halide, that is RCH2Br, 2Na. Suppose you take a aromatic compound. Suppose you are taking bromobenzene. You see, this is your benzene. This one is benzene, C6H6. If the one of the hydrogen atom represents bromine, so you can say this is your bromobenzene. When this is heated in solvent, dry ether, just like a Wurtz reaction, this get lost molecular NaBr. So this become what product will get? RCH2. There is a link with a benzene ring plus 2 NaBr. And this is called alkyl. This group alkyl group, alkyl benzene. What do you call it is? Alkyl benzene. And this reaction is known as, not Wurtz reaction, somewhat modified. It is known as Wurtz-Fittig reaction. What reaction? Wurtz-Fittig reaction. So, suppose you take mixture of methyl bromide and bromomethane. That is C6H5Br. C6H6 is benzene. If H is replaced by bromine, that's called bromobenzene. This is bromomethane. When heat a sodium in dry ether, what product will get? This Br, this will get lost, and this CH3 will link here. So this is became C6H5 CH3. That is, this is your benzene nucleus, and this is your CH3. This is known as toluene or methyl benzene. Okay, students? And this is called the reaction of alkyl halide with metal. That means reaction with sodium. When the alkyl halide react with metallic sodium in dry ether, that reaction is called Wurtz reaction. In Wurtz reaction, we can prepare the higher alkanes. And if the one of the molecule is aliphatic alkyl halide and other is aromatic alkyl halide, that will form alkyl benzene, and such reaction is called Wurtz-Fittig reaction. What reaction? Wurtz-Fittig reaction. Next come to a reaction with magnesium. So, you know magnesium is an alkaline earth metal. Its valency is 2. So, the alkyl halide, when react with pure and dry magnesium wire or magnesium, and heated in dry ether, you see this magnesium insert here. That is, the magnesium atom insert between carbon and halogen, it became RMgX. And this is known as alkyl magnesium halide. And this is alkyl magnesium halide, a very important compound. And it is discovered by the scientist Grignards. According to the name of the scientist, this sample is known as, this reagent known as Grignards reagent. And the Grignard reagent is C2H5 MgBr. This is ethyl magnesium bromide, and this is known as Grignard's reagent. And Grignard reagent is very important compound like alkyl halide. From Grignard reagent, we can prepare the various class of organic compound. Various class. We can prepare aldehyde, ketone, carboxylic acid, alkane, even the cycloalkanes. So many compounds can be prepared from Grignard reagent. Now come to, suppose if you take ethyl bromide, the reactive metallic magnesium, heat in dry ether, it gives you C2H5 MgBr. This is known as ethyl magnesium bromide. So this is the reaction of alkyl halide with metallic magnesium, and when the alkyl halide react with magnesium in dry ether, it gives you the reagent, that is called Grignard's reagent, and alkyl magnesium halide. Okay, students. Now, suppose the ethyl bromide react with the alloy of sodium and lead. This is a alloy. What is alloy? Alloy means mixing of two different elements. Means one must be a metal or there is a non-metal or metalloid. But in this case, lead combined with sodium, that's called is a alloy or lead sodium alloy. When ethyl bromide react with sodium lead alloy, it gives you a compound that is C2H5 whole 4 Eb plus NaBr. So what is this one? This is called tetraethyl lead. This is your TEL. L means lead. This compound is called TEL. TEL means tetraethyl lead. And this tetraethyl lead in old days it is used as a anti-knocking agent in internal combustion engine. What is this anti-knocking agent? You know, petrol is an octane, hydrocarbon. It is on combustion, it gives you mechanical energy. By the mechanical energy, your bike or scooty will run. When the consumption of the petrol is very high, very rapidly, then it forms a knocking sound like thud, 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 like this one. And that is called knocking. When the engine undergoes knocking, there is a efficiency of the engine decreases. To increase the efficiency of engine, you are adding some reagent that is called TEL. That's why TEL is used as a anti-knocking agent, but nowadays this is not used due to lead pollution. You know the ethyl bromide, what present is in combustion, it gives the lead compound, particularly lead oxide. And the lead oxide is a major pollutant, that is major air pollutant. If the lead causes so many diseases, so many harmful, the plant kingdom to animal kingdom. That's why nowadays this is not used. Okay, student, this is alveolar reaction of alkyl halide with metal. Sorry, the alkyl halide react with the metal like sodium, magnesium, or it can react with the alloy of sodium and lead. Okay, and last we come to reduction. What is reduction? Reduction means addition of hydrogen, removal of oxygen. So the alkyl halide on reduction means by treating with the reducing agent like tin and HCl. This will be reduced here. This side H, this side H. This became RH plus HX. Suppose if you take ethyl bromide when treated with tin and HCl, means tin metal dissolved in HCl, it liberates nascent hydrogen, and this nascent hydrogen can reduce this one, that is C2H6 plus. Means the alkyl halide get converted into corresponding alkane. This is your ethane, this is your bromo ethane. We can use so many type of reducing agent. Suppose you take zinc and HCl, zinc amalgam. Amalgam means it is an alloy of zinc and mercury in presence of HCl, and this can also be reduced with hydrogen in presence of nickel. The another one, the alkyl halide reduced to corresponding alkane. Okay, students, these are the reactions of alkyl halide, and we can summarize this reaction. So you see, we can prepare the alkane, alkene, alkyne, alcohol, ether, ester, primary amines, carboxylic acid, nitroalkanes, alkyl nitriles, so many class of compound can synthesize from alkyl halide. That's why alkyl halide is the most important or key compound for organic chemists. So during the conversion, try to convert this given sample into alkyl halide. From the alkyl halide, we can prepare the desired compound. And what you learn in the alkyl halide chapter, I can summarize a small table. You see this table each and every morning till you remember this. So I summarize this. This is your alkyl halide. The alkyl halide can be prepared from alcohol by the action of PC, PX3 or PX5 or SOCl2 or Lucas reagent. Means when the alcohol treated this reagent to form this called alkyl halide. The alkyl halide can also be prepared from alkene by addition of HX in presence of CCl4. The alkyl halide can also be prepared from alkane by halogenation. And the alkyl iodide can be prepared by halogen exchange reaction, that is your Finkelstein reaction. And the alkyl halide can also be prepared, or particular alkyl bromide, from silver salt of carboxylic acid. So from these compounds, alcohol, alkene, alkane, we can convert to alkyl halide. From the alkyl halide, we can get converted into various class of organic compound. That is, we can be prepared alkane, we can prepare alkene, we can prepare alkyne, so you will write a capital letter. So you can prepare alkane, alkene, alkyne, you can prepare alcohol, you can prepare ether, you can prepare ester, you can prepare nitroalkane, we can prepare alkane nitrile, we can prepare alkane isonitrile, we can prepare amines. So we can prepare various class of organic compound from alkyl halide. That is, the alkyl halide can we convert alkane by a reduction? Alkyl halide convert to alkane by alcoholic potash by elimination reaction. Alkyl halide convert to alkyne. It can react with alkenides, sodium alkenides. It can prepare alcohol by the action of aqueous KOH or moist silver oxide. The alkyl halide convert to ether by sodium alkoxide. The alkyl halide convert to ester by the action of silver salt of carboxylic acid. Alkyl halide convert nitroalkane by the action of AgNO2. Alkyl halide can convert to alkane nitrates by the action of KCl. And alkyl halide convert to alkyl isocyanide, that is silver cyanide. Alkyl halide react with convert amines, that is treated with alcoholic solution of ammonia. So many class of compound can be prepared from alkyl halide. Again, from this alkane nitriles. From this alkane nitriles, on reduction, it gives you primary amine. On hydrolysis, it gives you carboxylic acid. That's why alkyl halide is a most important compound for an organic chemist. From this one, we can prepare almost all the compound. Okay, students? So, you try to remember this. I will give some idea in this table. So, A is converted to B. Means B must be one of these one. And A is some of this one. So, A is first converted alkyl halide and alkyl halide converted to B. You go and practice. Okay, students, next class we will discuss some conversions, some doubts. Okay, and next class we will study the Halo Arenes. Okay, student, this much today, and go and practice. And practice, you can remember. If there is no practice, it can vanish. That's why the organic chemistry is very easy to remember, just like our mathematics, but we have to touch it every day. We can recollect, remember every day about it. If it is in your practice, it is easy to say. Okay, students, thank you, all of you. Next class we will meet again.